All right, page 103, 65 to 79 odd, number 75. Describe the x values at which f is differentiable. Well, we didn't really do this, so that's a good question to ask. It looks to be a asymptote at 3. So derivative means slope at a point, or slope of a tangent line at a point. Well, if there's not a point there, then I can't find a derivative there. So at x equals 3, there is no derivative because there is no function. A better way to say that is because it's not continuous. Because there could be an example where there is a function, but it still doesn't have a derivative. So the best way to say it is, if it's not continuous, you can't take a derivative. Everywhere else, it's continuous, so it's fine. Oh, let me make sure I answer the right question. Describe the x values at which f is differentiable. So it is differentiable. That's a fancy word for saying you can take a derivative at everything except 3. So if we want to write it fancy like that, that's make sure we answer the right question. So everything except 3, you can take a derivative. But 3 is not continuous, so you can't take a derivative there. What else?
Can you do question 69?
69. Use the alternative form to find if the derivative, well, if it exists. Find the derivative and see if it exists. So it'd be nice if I knew what that picture looks like. That way I'd have an idea of if what the derivative is, like if it's positive or negative, if it's steep or close to 0. This absolute value thing is kind of a mess. So let's split it up. If x is bigger than 0, then it's just the square root of x. So it's just normal square root graph. If x is less than 0, then we would change the sign of the thing in there and then take its square root. Something like that. So a backwards one. Okay, so now it wants us to say at 0, so at that point. Well, here's another place you can't take a derivative. Can't derivative, turn derivative into a verb there. You can't derivative at a cusp or a sharp point. So there is no derivative there. That's a good one. That's a tricky one. Because we didn't talk about cusp and sharp points yesterday. So you guys are asking the right questions, the stuff that we didn't quite discuss. And this is a big deal. This will happen a lot this year. So at sharp points, you can't take a derivative. Which kind of makes sense, because if the derivative is the slope, how are you supposed to find the slope at a point where it's a pointy spot? There's not a way to draw a tangent line there. So kind of stuck on that one. What other questions? Good with like 71. This sort of answers some of those questions. 65 should be easy. 67 is just algebra. All right, you asked the hard ones, so you can be good with that.